Okay, let's see one by one. There are everything are same, but here we have divided according to the question function and question types. Okay, so first of all, put type 1. Okay, so the type 1 for solving this auxiliary equation type. Okay, so can you write down here? So suppose that one of the variable is either absent or cancel out from any two fractions. As I said, we have two fractions in it. This is one of the fractions. This is, we can take either this and this, or this and this, or this and this. Okay. Suppose that one of the variable is either absent or cancel out from any two fractions of given auxiliary equations. Okay. Then integral can be obtained. So as I earlier for my question, the answer is integral. So dx over p, which is equal to dy over q. So how you can get the answers? Using some integration, no? So no, only one person answered. So then integral can be obtained by usual methods. Okay. So in this type, if you have this for this one, if you have absent or any of this variable cancel out, we can use our integral and usual methods to solve it. Okay. Okay. So under this, you can write this. Okay. Suppose that one of the variables is either absent or cancel out from any of two fractions given auxiliary equations. So you can name this as star. So auxiliary equation star. Then integral can be obtained by usual methods. Okay. Okay, let's move to the examples as given. Okay. So I'll erase this one. Okay. Now let's see this example. So is that in the Cauchy linear form? If so, in what? In how? Okay. So that is our step number 1. No? You have to transform the whatever the given equation into this form. What is that form? PP plus QQ, which is equal to R. You have to transform in this form. Is that in this form? Actually, they didn't give in this form. So you have to make it in like in this form. So we know P is there, Q is there. This side for R, we have 1. A is something, it is a can. So you have to take, first of all, you have to cancel out the brackets. Like it is simple now. AP, AQ, it is equal to 1. So it is in this form now. So it's like what is our capital P? So capital P is A, capital Q is again A, R is equal to 1. Okay. So this is your first step. You have to arrange the equation to this format. Okay. And then, so we continue. What is our second step? Second step to write the Lagrange's auxiliary equations. Okay. So let's go back to that. So here they have continuously given the number. You can put 1, 2, 3. Okay. So when you are writing the answer, you just put 1, 2. No need to put 11, 12. Okay. So 1, 2, 3 like that. Okay. So given equation has been transformed in this form. So as we know, the Lagrange's auxiliary equation of this one is what? Dx over capital P, dy over capital Q. So first of all, you write this. These answers are very short answer. When you are writing, you write a full answer. First of all, this is our Lagrange's auxiliary equations. Okay. Then you have to substitute whatever this. So we have found P is equal to A, Q is equal to A, R is equal to 1. Okay. So we have two fractions, this and this, or even this. Okay. So you can take whatever to solve out. Our thing is we have to get two, constant, arbitrary constant. Okay. So taking the first two, see how nicely they have written. So this is how your answer should be in the examination, or even now also you practice in this way. Okay. Taking the first two members of, let's say 2. So what is the members? See, dx over a. So don't write these answers. Okay, these are short answers. You write nicely in order. Okay, dy over a. So you can cancel out these two. So we will end up dx equal to dy. Okay. So if you they are taking in this way. Okay, dx minus dy, which is equal to, we don't have nothing. See. So when you're integrating this is they taken as the equation number 3, and then integrating, we will have what? What is the integration? So you can put like this: integration, integration, integration. So if you are confused, you can write like this. So integration of dx, what is the answer? First of all, don't copy this answer. Okay, just write with me. I'm writing your answer nicely. So you copy my answers and follow with me. You know everything. You don't need to copy or anything. All the things that you already know. You have the knowledge. Okay. Okay. So from integration of dx minus integration dy, we have integration 0. So we know integration of dx is a function x itself, no? Divided by 1. So we don't need to put. Similarly, integration of y will be, dy will be y. So we don't have nothing for constant. So we have to put one constant, arbitrary constant c1. Okay. Again, this is equation number 4. Then, so we have found one pi, no? This is we're going to take as a pi, isn't it? So we can write like nicely like this: pi x comma y is equal to c1. Why I'm putting x comma y? Because we are dealing here only the x and y terms, no? So that's why. Okay. So we have found our pi. Similarly, you have to find the chi. So you can either choose this one or this one. Okay, these two. So anything okay. Okay. So let me use this one. So whatever they have taken the last two members. See, they have nicely written last two members. What are the last two members? dy over a, which is equal to dz over 1. Okay. So if you follow the same steps, so here you better cross multiply. Dy is equal to a dz. Okay. And then take the integrations. Both sides you will have. So you can take this side, so which is equal to 0. If you take integration, this will be y minus, tell me the answers, az. Am I right? Which is equal to c2. Yes. Okay. So you can take that as the equation number. Yeah, this is 5. This is 6. Okay. So here you can say this is our chi. Okay, chi also is a function. See, this has because that is a function of x comma y now. Maybe in this equation, x and y there. In this equation, we don't have x, but we have y, and z also function of x comma y. So chi is a function of x comma y. So I can transform this C2. Okay, this is my pi. Okay, and then using the 4 and 6, sorry, 5 and let's say this is 1, 7. So you can try 5 and 7. The required solutions, as I said in our theorem, as well as the working rule, you have to put pi and chi of a arbitrary function g, no? So our, okay, you transform this was a g, okay? So our function, our last solution, you have to put, what is pi? Pi is x minus y. So x minus y, comma, what is your chi? Chi is y minus az, which is equal to 0. It's our solutions. Okay, this is our required solutions. And then you have to tell g is being a arbitrary functions. Understood? Hope you written what I have told you. Okay. Okay, shall we do one more? I'll give the question, wait. Okay, can you answer me the second example of for this type 1, okay? This type 1, let me say, can you answer me solve? So we are transforming some A, rather than A and B, we are putting some numbers, okay? Can you solve this one? You have to use all the nice steps and you can try like step 1, step 2, that will also good for you, okay? Step 1, step 2, like that. Can you give your final answer G? So within 2-3 minutes. So it's not big deal. So can you give me the answer quick as possible? Everyone should answer the questions. I will call some people also. So all should have the answers. Can you write the function nicely g inside the g? 077, can you check your second one? Second functions. Okay, you use the other one, no? So you better use one method, okay? Like first of all, you take the first two, and the second you use the last two. Okay, so it will give you. So that's how the procedure goes. Use first if it is dy over p, sorry, dx over p, dy over q, dz over r. First you choose this one, and second you choose this two. So it will give you a correct answer. Okay. Okay. 081, can you answer me? Sometime in some book I have noticed like they have take for in this because we are taking pi and chi, and then we are putting g is equal to 0 now. So in some book they take this as a u, this as a v, and this as a pi. Okay, so pi u comma v. So this is also same. Okay, don't take differently. So as a mathematical people, they can choose their own variable now. So for here we are choosing pi and chi g. Some people use u comma v and this as a pi. Okay, so don't worry about that. Everything are same. Okay, hope many of you has answer correct. Where's the 081? If I ask someone, they are telling they always no signal problems and stuff like that. I think they are not in the class. That's the problem. Okay. 081, come quickly and answer me. Okay. So I will take this one as our answer should be, yeah, this is easy, no? 3x2y minus y minus 3z, which is equal to 0 is our final answer. Okay. So I'll give you some exercises so you can keep some spaces. You can try as a homework. Okay. So one other one will be solve exercises. Number 1, solve yzp plus 2xq, which is equal to xy. Sometimes they may give in a order, sometimes they don't. So you have to make it. Okay. So let's say second one. Can you solve this one? Y squared z over x of p plus xz q and y squared. Okay. So practice makes the things easier. So you can do some extra practices. Okay. So can you try this one? Fourth one, xp plus yq is equal to z. Okay, you have to, you have to type that in between the capital G, okay, as a function, whole answer. You have to include that inside the GN as in this form. Okay, please copy the questions so you can try all. So I have some more, you can. So this is a kind of type 1 questions, okay? So I'll write the fifth one here. Fifth one may be P plus Q, small p, okay? P plus Q is equal to 1. Sixth one. So just copy the question and you can try as a homework. Okay. So there are 7 questions, so you can try. You can write solve like this. Or you can write as a question, solve the following questions. Okay. So use all your knowledge of integrations and things, okay? That's nothing, just the integration. Okay, have you done copy? Shall I erase? This is a Y. Okay, let's continue our notes. So this is all about the type number 1, okay? So put the B as type number 2. B as type 2 for solving the same, the auxiliary equations, okay? So it just, okay, some kind of example. Let me see. There's nothing to write, just let's start from the example, okay? Okay, so can you put this example? So we can do by this example. Solve this kind of equation. Z, x at p plus y z q, which is equal to xy. So this kind of equations, okay? So type 2, for example, x at p plus y at q is equal to xy. So the working rule is same. So the solving method can be little bit of differences from the type 1. Okay. So let's solve this one. So given equation is this. Okay. So it is already in the form of PP QQ is equal to R. So the Lagrange's auxiliary equations is, what is that? Dx over P, which is equal to dy over Q, which is equal to dz over R. So if you substitute whatever our P, so here you can find out, if you write separately, it will be very easy for you to just to substitute. Okay. Q is equal to yz, R is equal to xy. So just substitute dx over xz, which is equal to dy over yz, which is equal to dz over xy. Okay. So then step number 2, taking the first two fractions, you can number it also. This is equation number 1, equation number 2, like that. Okay. Fraction number 2, we have, what is the first two? These two, isn't it? So it will be dx over xz, which is equal to dy over yz. So this will be the common term. You can take it out. So what do you think? Dx over x equal to dy over y. So integrating, what you'll get? So our meeting again gonna finish within 10 minutes. That's okay. So give me the answer quickly. What is this? Integrating 1 over x dx. Integrating minus, we can take this side, 1 over y dy, which is equal to integration 0. This answer. So these are we already very familiar now. So I will erase this board window. Okay. Hope you have copied everything. So yeah, one of the person answers yes, yes, yes. The others. So you have ln x minus, so integration of 1 over x dx is the ln x. Okay. So similarly for this one ln y, so it's better you to take the arbitrary constant also. It's a log or ln, anything. Okay. Log form, ln form, anything. Okay. Okay. So then you can use the logarithmic rules, ln x over y, because of the subtraction. Okay, this side ln c1. So you can equate the both part. That will be x over y is equal to c1. Which means what? Which means we have found our pi xy, which is equal to x over y, which is equal to c1. Okay. Similarly, taking the last two fractions. So I'm not going to do everything. Okay. So it's same, no? Is that same? Okay, small differences. Let me see. This will be D. So dy over yz, which is equal to d. Okay, dz over xy. So y and y cancel out. So this is a little bit difficult, no? So that's what the I mean type number 2. See here. Here we have z. Okay. Here we have x. So is that possible you to get dy and z dz? Is that possible you to get this one? Okay, that's a small difference. Okay, I will do that again. So it means we have remaining dx over xz, dy over yz, okay, dz over xy. So we have chosen this one. We have got one c1. Okay. So other one is if you choose these two here, if you cut out this y and y, we have x and dy, z and dz are okay, but x and dy is there now. So we can't choose these two. So let's choose again the same thing, but we're going to use our earlier things. What is C1? C1 is x over y. So from this, what is x? Y C1. Am I right? So I'm cross product. Okay. So this is what the differences from type 1 to type 2. Okay. Somewhere we may have like this. So there you have to substitute whatever your C1. So again, I'm going to take my dx over xz, which is equal to dy over yz. Okay, that is what the possible one. Yeah, give me a second. Yeah. So then you substitute for what's happening. I think you can have this one dy over yz and dz over. Let me try this way. Okay. So again, I can cut out this one. So I have n x dy minus z dz, which is equal to 0. Okay. Here I don't have y to have the integral, but I have this one. If I substitute this one, I can get the y again. Okay. So I'm gonna substitute for c1 this one. Okay. Y c1 dy minus z dz. Now it is okay, no? Am I correct? So now if you're integrating, what you'll get? So this is a constant, so no problem. You can take it out. So y dy, what is that? For y dy integration, y squared by 2. Am I right? Am I right? This one. So integration of y dy is what? So you have to add one more, no? 2. And you have to divide it. What do you get the power? So that's what here. Okay. C1 is a constant. Okay. So for similarly for integration of z dz also, z is squared by 2. Here I can use my other constant C2. Okay. So the same thing I'm using, same type 1 I'm doing. Okay. I'm taking again my 2 last fractions. Okay. But without this substitution, I can't solve. Therefore, I am substituting from my earlier C1. I'm putting here. Okay. So shall I erase this window? Okay. Okay. What I have done is I got like half. Sorry. Yeah, I can write it this way. C1 y squared by 2 minus z squared by 2. So here C2 also I can, because these two are having half, you know this knowledge, no? According to that, if you want a nice constant, you can arrange your constant also in the same pattern. So it will give you a integer one. Okay. So my last answer will be this Z2 square, which is equal to C2. Okay. Okay. Now, so we have found our pi xy, which is equal to x over y C1. But here see that in our this is C2. Okay. This is our chai. If I wanted to take this one as a chai, this doesn't need to be there. No, this is our constant. We can't put pi element to the chai element. So what I'm gonna do is I'm gonna rearrange again after solving. See, I can C1y times y. So y squared I can write like y and y minus z2 squared is equal to C2. So what is C1y? It's already given, isn't it? xy minus z2 squared is equal to C2. This is my C2. This is I can take as a chai, x comma y. See, a simple difference from the type 1 to type 2. Okay. All right. So if that's so, my final answer will be pi and chai is equal to 0 is what? It's not a problem, no? So I think our meeting will be finished soon. So you can join again, okay? So for pi, I can put this one. Chai, I can put this one. Okay? This is equal to 0. So small differences. So when you are writing again for the chai, you don't have to use your earlier C1. You have to again replace the whatever you have taken. Okay. So this will be the type 2 answers. So if the meeting finish, you can join again.